Hello everyone, and this will be a video tutorial slash sample of how I got a 23 out of 24 in my physics IA. As you can see right here, the moderated mark was 23, and the IB, and the teacher in my school gave it a 23 too. And that's level 7. So I'm gonna show you my IA, what I did, hopefully some tips on what you guys can do, and yeah. So let's just close this. The most key thing to know is that for an IA, the question has to be like, how does X affects Y? I mean, you can do an exploration or modeling, but it's pretty tough. I would suggest a practical experiment. Basically, how changing X or the independent variable would affect Y, your dependent variable, or what you're measuring. So my one was an investigation of how changing the salt concentration affects the maximum mass the bubble of solution on top of a coin can hold before its meniscus breaks. So it might get complicated right here, but it will get easier later on. So my experiment is basically like this. You know, if you have a pipette and you have a block of coin and you put water on top of it, somehow when you put too much water, the meniscus will break, like here. And my experiment is to show how the salt concentration would affect the maximum mass of solution it can hold on top. So that's a pretty cool experiment that I somehow thought of. I didn't know why. So let's look at the success criteria. Number 1, of course, would be personal engagement. Exploration is be like the first 4 pages, analysis and ladder for evaluation, like the last 1 or 2 page. Personal engagement is really easy to nail. Everyone should get 2 out of 2. It says, what does it say? It should show evidence of independent thinking, creativity, initiative in designing, implementation, or presentation. Justification for choosing the research question is given, which demonstrates, again, personal interest, personal significance, interest, or curiosity. There's evidence of personal input and initiative. Like, everything has to be present, and you have to justify why. So let's not read my one, but basically what I said was that in this experiment, physics of surface tension was significant to me. I gave an anecdote. I don't think you should do this. This is a bit too extra, but I think since I got 2 out of 2, and my one actually got moderated to the IB, so the IB likes it, so you can not copy this, but copy the style. So I said, along the beach in LA, I sat on the table while sipping a nice cold glass of water. I looked up and saw my parents putting the change of coins they bought from the cold bottle of water on the table. I carefully observed my sister playing with straw and cold water. Like, you know, when you have a straw and you control the pressure up, down, and then drops of water would drop down. That's pretty cool. I thought to myself, wow, so how much water can the coin hold before breaking? Like I showed the meniscus. So as I put my arms around the table, I had a deep moment of thought, and drops of seawater dropped down. Ooh. So then I thought, do different solutions have different surface tensions? So then I demonstrated my personal initiative and input, as I stated. I thought of different ways of measuring surface, the relationship between. Immediately, I already have how does X affects Y. So how does the salt concentration affect the maximum mass or the volume before it breaks? So I thought of this method, but in the end, why not perform a simple experiment by changing that? So with this interest and curiosity, I personally decided, I even used the word personal, decided to design and implement, right here, design, implement, investigation based on this personal anecdote. So that got 2 out of 2. So after that, how should you structure it? Once you have your personal engagement, which is 1 page long, you should have a research question, which should really be fast, and it has to be very precise. So my one is, how does the level of salt concentration, basically how does X affects Y? That's basically it, right? And then what you have to do is give relevant background information. So just state the theory behind it, and you have to do your additional research. So I stated a bit of, I don't know, H&O bonds. I forgot all about this. This was 6 months ago. So yeah, and then that, and that, and then somehow, let's look at the criteria again. Exploration states that you need to have a very fully focused research question. Okay. So background information is entirely appropriate and relevant and enhances the understanding of the context. And then it says the methodology is highly okay. So you have to have a hypothesis, or basically a prediction of why one is the case. But you have to justify that hypothesis and you have to give reason why that's the case. So my hypothesis was that an increase in the mass of salt or concentration would result in a positively linear increase in maximum mass of droplets of solution to break the meniscus up until the mass of salt added in a solution is 75 grams, which is the saturation point. So I justified, or I gave background information of why it is a positive linear increase. I demonstrated why it was a linear increase because of why it was a positive increase because of this theory right here, and I stated why it was linear because of this theory right here. See, you have to justify every single reason. You can't just say as x increases, y should increase. You have to state exactly why, and if you state that it is directly proportional or positively correlated, you have to state why it is positive, that's number one, and why the two variables are linear or directly proportional. Or you could say it curves exponentially, but you got to state why it is positive and why it curves exponentially, both of them. So that took a while and lots of tedious math, but I did get it done. And finally, independent variables, you got to state why. What will you change? Get clear units, and you could say the experiment will be conducted in XXX different concentration levels. If you're doing different height levels, blah 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 blah, up till a certain point where you got to justify why you do it until a certain point. Dependent variable, what you're gonna measure, using what, and in what units, and the level of precision you have to justify why, right? So that's cool. Control variables. You have to state what you're going to control and why. You can model it like my EE. You could do a control variable, why it's needed to be constant, how it was kept constant, and the value. Be careful of the sig figs. Make it to the level of precision of the apparatus that you're using. Sorry. And then let's look at the success criteria again. Yep. And then it says it will show full awareness of the significant safety, ethical, and environmental issues. See, people ignore this bit a lot. So you just gotta do some BS. Safety issues, ethical issues, and environmental issues. Safety issues, follow the CLEAPS guide, CLEAPPS. Do your experiment, type CLEAPS, go on Google, and then not copy paste, but state the hazards. Ethical issues, I state it because since I'm using a coin, there's to show respect for the king. Heads, I use the tail sides instead of the head side. And environmental issues, state some BS about saving water, saving salt. I don't know, up to you. And then the method could be method of like 1 2 3 4 5 6 7 8 9. It's a bit tedious, or you could do it like my EE, which is oopsies, it's a procedure like that, which is pretty cool too. Like do that, and so on. It's easier too. So once you have done your experiment and you've repeated your results like 3 times, you're going to put it in a collection of your summary table of results. This is the summary table of results. You're gonna have raw data. So raw data goes in the appendix right here. Raw data. What you're gonna do with the raw data is you're going to find the average, and then you're gonna do a propagation of uncertainty. This is very easy, and let me show you how it's done. Propagation of uncertainty basically means this. Let's look at that for example. So we just gotta do that plus that plus that plus that plus that plus that plus that equals that. Add all together, find the average, basically the average. Propagation of uncertainty is basically the largest value in that range set, so 1.48 here, minus the bottom, minus the average right here. So you get 0.04, for example. And then you do the lower bound, which is 1.41. So you do the average minus the lower bound, which is 0.03. And then what you do is you find the absolute uncertainty of the uncertainty propagation by adding the upper bound plus the lower bound divided by 2, which gives that 0.035. And then you find the percentage propagation of uncertainty by 0.035 divided by whatever the average mass is times 100, which gives you a percentage. And that percentage should be placed here. Here. So you got to do that for your readings. That's basically your percentage uncertainty. Propagation of uncertainty. Yeah. So what you then would have to do is get a graph. Once you have, remember, this top bit is just processed data. Your raw data should go in appendix and it doesn't count towards your word count. Processed data, you can use that using Logger Pro. I use it using Logger Pro. You did the maximum bounds, minimum bounds, and the average bounds. And then do a bit more research. See, this is the hard bit because I can't teach you what to do. So basically, state why your hypothesis was correct or not, and then do a bit more analysis. I did some side analysis, but I don't think you need to do that. I even stated if you need some space or you have some space, do the standard deviation and root mean squared error. Yeah. And then finally state your conclusion. Qualitatively why it's correct, quantitatively why is it correct, and so on. This is, I know it's, I skipped past that bit, but it's actually whatever your data or experiment is. I can't really help, but yeah, pretty much it. Just do your uncertainty as well, and then yeah, evaluation. I stated my evaluation as what went wrong and some solutions, and I stated quantitative and qualitative data analysis, what went wrong with accuracy, what went wrong with precision. Remember, these are different, completely different wrong terms. And quantitatively demonstrate what could have gone better if you had done your experiments better. Sorry, the value, the new value, if you did do your experiment better. So let's, or you could do it that method, or let's look at my EE, what I did, or you could just do that. Error, what type of error? Type of error, was it a systematic, uncertainty, random error? Was it how your impact on the investigation? Good, bad, significance, potential solution, and your actual value for what it could have been if you had implemented those changes. So that's about it. IA is way easier than your E if you're doing a physics E. But it's very straightforward, I guess, and communication just has to be clear. That's pretty much it. I suggest doing an experiment, of course. You can nail personal engagement, you can nail exploration well. Analysis would be hard. I mean, you just have to just answer your hypothesis and give the science behind everything. And if you don't understand it, then don't put it down. Make sure you understand what you're writing. And the evaluation should be pretty clear too. So a conclusion, what happens, strengths and weaknesses, and realistic suggestions and improvement, quantitatively and qualitatively. I think hopefully that's it. Don't copy my IA because this one got sent to the IB. So if you copy it, it's your own fault, and then you're gonna get plagiarized, flagged for plagiarism. Good luck, guys, and hopefully this video has helped you.